In this video, we're going to talk about generalization. So we're looking here at a map through Google Maps, and you can see here that at this scale, zoomed out, on these coastlines, we can see that there's a complicated coastline. But whenever we zoom in on it, something weird happens. You see the edges, they become a little bit more detailed as you zoom in each time. And so what's going on here? Why are the coastline edges becoming more detailed as we zoom in? Another good example is here in Alaska. As you zoom in around here, there's a very complicated coastline. But as you zoom in, you can start seeing that the edges get a little bit more detailed as you zoom in. And so what's going on is that Google, in this case, is using generalization. So as you zoom out, it's generalizing the polygons of the coastline. So what exactly is generalization? If we look here, for example, why are they doing that? Here we have a coastline that is ungeneralized at 1 to 150,000 scale. And you can see here, you can see all these little points. And here in the generalized version, though, you can see that all this gets kind of erased. It gets kind of smoothed out. And when you're zoomed in, the ungeneralized is always going to be much better than the generalized because you're losing a lot of data. But as you zoom out, that's when things get a little bit more complicated, and that's because the lines get jumbled together. So you can see here, this same little area, when zoomed out, the lines all get pushed together. So in here, the generalized one is going to look much better than this one. It's actually going to communicate better to the map reader. The map reader is going to see this and see coastline. Here they're going to see this and say, what's all this mess around here? They're not going to understand that that's coastline. But whenever you zoom out a lot, that's where it starts becoming almost necessary. So here's at the 1 to 1 million scale. And you can see here the lines become so on top of each other, they become just really black areas around the coast. While here in the generalized, you actually see a coastline. And so this is the most important aspect of generalization. It's really to make map reading much easier for the map user. So the key of this is that generalization is a method where the information that we're trying to display is on the map, that we're trying to represent the map, in this case the coastline, adapts to the scale of which is being displayed. It's not necessarily preserving the information perfectly. It's actually generalizing. It's losing information. So you can see here, this information is gone over here. But what it does do is that it makes the useful information of the map clear. So what's useful information of the map at the 1 to million scale here, for example, is where the coastline is. Yes, it's not going to show as much detail in the coastline as the ungeneralized, but where it is actually more important than this kind of confusion here that you're seeing with the ungeneralized one. So generalization is really used to represent the same data at different scales. So depending on what scale you're viewing the data in web maps, they're going to show different generalizations. So whenever we're zoomed out really far on the Google Maps, it's going to show a very generalized one. As we zoom further and further in, it's going to show less generalized until finally ungeneralized maps. And you can see here, for example, at two different scales, here's one where it's generalized in the red line, while the blue line is not generalized. So you can see that here, for example, all this blue information will be gone when we're zoomed out, but as soon as we zoom in, the red will go away and the blue will show up and show that more detailed. And that's what is happening on your web maps. So how do you do this? People do this in GIS systems, and there's tools like Simplified Polygon, which is going to be doing it for you. And so to do a little experiment, I ran this Simplified Polygon on some GIS files. So here, for example, is the original coast line file, and this is Maine. And you can see here at this zoomed out level, we're having this problem where the coast is so complex that we're getting all these kind of jumbled black lines, and it's really distracting for the map reader. It's hard. And so looking further at it, we can say what happens if we simplify it with the 1000 meter simplification setting. And you can see here the difference between this and this. It got rid of a lot of different information here. And this 1000 meter setting might be good for intermediate scale. But at this high of a scale, the 4000 meters is probably the most appropriate. And so here we can see that at 4000 meter, one of the higher generalizations, we have a very easy to read map. This is probably what most likely you're going to be seeing at a very zoomed out level. But whenever you zoom in very close, again, now the simplified to generalized is not going to be what you want, because here we're losing so much detail. But if we look at the 1000 simplification, it's a little bit better, but actually here we can go with the original coastline because we don't want to lose all these little islands and all this detail when we're zoomed in. So the summary is that when you're looking at maps, the cartographer is deciding on how to do some generalizations to make the map easier to read. A very well generalized map are maps when they emphasize the most important elements of the map while representing the world faithfully in a recognizable way. So the idea is that you don't want to generalize to where you start lying with your maps, but you want to generalize to make it easier to read, but you have to keep in mind that generalization is erasing information from your map. You are getting rid of information. So you have to start deciding what is the most important information on your map, what's the most useful that I want to show, and then how much simplification is allowable for me in this.